Hello everybody. Welcome to the understanding of failure of World Trade Center by Dish Committee. So I was studying about World Trade Center. So World Trade Centers began on August 5th, 1966, and they were officially opened on April 4, 1973. They were destroyed in a terrorist attack on 11th September 2001, about 21 years ago. The towers were designed as frame tube structures which provided tenants with open floors plans uninterrupted by columns or walls. This was accomplished using numerous close-spaced perimeter columns to provide much of the strength of the structures. Along with gravity load structures with core columns above the seventh floor, there were 59 perimeter columns along each face of the building, and there were 47 heavier columns in the core. All the elevators and stairwells were located in the core, leaving a large column-free space between the perimeters that were bridged by prefabricated floor trusses. So, before impact, this is the picture. After impact, this is the picture. We can imagine what is. I was wondering, so I researched and I found some new articles, and based upon those articles, I'm going to tell you what may be the cause according to those articles. So, like all modern skyscrapers, WTC towers were designed to survive major fires. Fireproofing was done also added after a fire in 1975 that spread to 6 floors before being extinguished. Early tests conducted on steel beams from WTC show that uh, they generally met or were stronger than the design requirements. In a less common move, designers had also considered the consequences of aircraft impact. But in 1993, John Skying, who had been in charge of the structural design of the buildings, said that an aircraft impact would cause a great deal of damage and loss of life, mainly because of the ensuing fires, but the structure would not collapse. After 2001 attacks, Leslie Robertson, who had participated in the structural design of the towers, said that the towers had in fact been designed to withstand the impact of largest airliner of the day, the Boeing 707-320. In the event, one was lost in the fog while looking to land. According to Robertson, the aircraft weighed 2.63 lakh pounds with a flight speed of 180 mph, as in approach and landing, which would have been much lower than the actual impact of the 9 by 11. The Tower of World Trade was so designed to withstand the forces caused by horizontal impact of a large commercial aircraft, but it did collapse. The reason was, according to the papers I referred, was dynamic consequence of prolonged heating of steel columns to very high temperature. This heating lowered the yield strength of the steel and caused the buckling of columns of frame structure along the perimeter of the tower and columns of building core. So you can see here 1, 2, 3, 4, 5. So the plane crashed at that one point, and what happened after the collapse? See it here. After the collapse, first when the plane hit, it heated up these columns. Once it heated up, the yield strength lower. So this becomes like an impact. So this whole weight is standing on a very few columns, that is the inner core 50 or some columns. Once this collapsed, the it's just like a hammer going on that building. So subsequently it all went on collapsing. Maybe this is one of the possible explanations which may be said about the collapse. So it can be validated based on the existing pictures also. So you can see that there are how it collapsed. So once this is done, so stage one, there was a great fire caused by aircraft fuel spilled into the structure, caused the steel columns to be exposed to the steel columns to a very high degree of 800 degrees Celsius. The heating is accelerated by loss of protective thermal insulation due to the initial blast. As such, at such temperatures, structural steel suffers a decrease of yield strength and suffers a viscoplastic deformation. This leads to the creep buckling of the columns. Once more than half of the peripheral columns get means get uh, cut due to this heat and this impact. Uh, the columns start buckling, due to which the weight of the upper part of the structure can no longer be supported, and so the upper part starts falling down on the lower part of the critical floor, gathering speed until it impacts the lower part. At that moment, upper part has acquired an enormous kinetic energy and significant downward velocity. The vertical dynamic load on the underlying structure far exceeding its load carrying capacity, although it is not heated. This causes the failure of underlying multiform segment of the tower. The failure of connections of floor carrying trusses to columns is either accompanied or followed by buckling of core columns and other all buckling of frame tube. With buckle properly spanning, the buckling is initially plastic but quickly develops fracture and in plastic is then impacted by even larger mass of falling with a series of impacts and then failure proceeds downwards. The details of the failure process after the decisive initial trigger that sets the upper part in motion are of course very complicated, and their clarification would require a lot of uh, computer simulations. For example, the upper part of one tower is tilting as it begins to fall. The distribution of impact forces along the underlying columns of the frame tube and core, and between the columns and the floor supporting trusses is highly uniform, etc. However, a computer is not necessary to conclude that the collapse of majority of columns of one floor must have caused the whole tower to collapse. This may be demonstrated by following a empirical criteria in which simplifying assumptions most optimistic in regard to survival are made. So, for a short time after the vertical impact, the upper part, after the electric wave generated by the vertical impact has propagated to the ground, the lower part of the structure can be approximately considered to act as an elastic spring. Its stiffness is C can vary greatly with distribution of the impact forces among the frame tube columns between those columns and those in core and between the columns and the trusses supporting the floor slabs. The impact forces among the frame tubes between these columns and those in the core and between the columns and the trusses supporting this. For our purpose, we imagine that the impact forces go. into the columns and are distributed among them in unlikely. Though such distribution may be, it is nevertheless the most optimistic research hypothesis to make because the resistance building to the impact is is the highest. If the building is found to fail under uniform distribution of the impact, it would fail under any other distribution. According to the hypothesis, one may estimate C as 71 giganewton per meter due to the unavailability of precise resistor in approximate design of columns assumed. So during the initial drop of the upper part may be neglected. That is, the part may be assumed to move through distance h almost in free fall indeed. The energy dissipated in the columns during the fall is at almost 2 pi into yield moment of columns into moment of number of columns, which is found to be only 12% of the gravitational potential energy release. If the columns are cold and much less than that of 800 degree, so the loss of gravitational potential energy of the upper part may be approximately equated to the strain energy. So mgh, that formula is there, is equals to p square by 2c. M is equals to mass of the upper part of north. It is approximately 586 into 10 raised to 6 kg. Solution P is equals to P dynamic. So P by P naught from that equation gives approximately 31 times the load bearing capacity. This is the second approximation of the load coming. So due to the uh, sudden impact, you can see that the load coming on the building is 31 times the capacity. So yeah, you can see, yeah, it validates the gravity driven collapse to be consistent with the observations. The present analysis further may prove alternative hyper control deformation to be incorrect as per the papers. So this is a study. Thank you. This was an old PPT we made during our B presentation. So based upon the web data, the data above may be not reliable, but may give rough idea of what is how the World Trade Center failed and may help the future buildings to avoid such. So now you this Burj Khalifa and all, you can see that it is in same type of cone. As the building goes above and above, you can see that the uh, floors become smaller and smaller. So this is the basically the learning that we have gained from it, so that in order to avoid gravity driven collapse and build much safer structures. Thank you. Thank you once again. Thank you all.